This morning I had the privilege of introducing Indrajit Chabi, a friend of mine, and this next person's also proud to call a friend. Our next speaker is Kyle Douglas-Mankin. He's a former professor at Kansas State University and a former, which should, you know him, should get your attention, senior hydrologist at U.S. Fish and Wildlife Service. In August, he will begin working as the USGS surface water specialist in New Mexico, and he'll be located at the New Mexico Water Science Center in Albuquerque. His expertise and experience include surface water hydrology and natural treatment systems. As most of you probably know, he serves as the ASABE division editor for NRES now. He's really been instrumental in elevating the visibility of our journal, especially our division's efforts with special collections. And to me, he's done an outstanding job of balancing the need for scientific rigor with the time involved in reviews and then servicing our authors and publisher as well. But most importantly, he's an amazing person. He's got a heart for mentoring students. He teaches them about ethics, stewardship, service, and professionalism. And then I think he sets the same example for us as professionals. And I'm very proud to be an ASA member for people like Kyle. So with that, Kyle, you're up.
Well, thanks, Darren, for that kind introduction. Appreciate that. And I also appreciate Rafa. You can look up Rafa. Appreciate Rafa and the committee for putting together this whole concept of an invited speaker session. I think it's turning out to be really successful. I hope you'll feed us back some information about how it's going. But I appreciate Rafa's work and the whole committee in steering us in this direction, and particularly to get us talking about ecohydrology, which is certainly gaining momentum internationally, and ASABE certainly has a role, a leadership role in addressing ecohydrologic issues. So I'm batting cleanup in the session this morning, and what my goal is to try to help us understand where is ASABE currently in this ecohydrology field? What work have we published? What is our leadership? I think as the committee kind of wrestled with this whole session, we had this kind of intuition that ASABE is heavily involved in ecohydrologic research, and yet if you do any type of literature search on ecohydrologic terms, transactions of ASABE does not rise to the top of your screen. And so what is this disconnect? And so my goal here is to try to somewhat quantify, but certainly try to understand what we're doing currently in ASABE, and what are our strengths, what are our limitations, and what are the kind of the need for us to improve the scope and complexity of our ecohydrologic research. So with that, it sounded easy. I think when I first was talking to Rafa, it's like, yeah, just give me 5 or 10 minutes and I'll summarize what's going on in transactions. But it ends up being much more complicated than that. We as a society don't always identify ourselves as ecohydrologists. I talk with many people who I think are in ecohydrology, and they don't really identify what they're doing as ecohydrology. So when I went into the journal and I tried to define what was ecohydrologic research, it was a challenge. And so I had to go back to understanding what is ecohydrology, and you'll kind of get a glimpse at my mind here as we walk through what those potential elements are. And then I'll go and I'll try to apply some of those key concepts to assess what has been the ASABE publication history in that regard. And I'll summarize a content analysis where I go back at issues throughout the 60-year span of transactions and try to summarize how well we've been hitting some of those scope and complexity targets. Then we'll consider what should be ecohydrology, and I'll pull out, if I have time, I'll pull out a few examples over the history of ASABE, of where I think we've done a particularly good job. And together in this roundtable, hopefully that'll set us off to dreaming about what the future of ASABE and where our leadership potential is in this ecohydrology field. So, some definitions. I really liked Dr. Rinaldo's definition. Very simple. Water influences biota. Water controls biota. Very simple. I think Dr. Chauby also took that the next step and said, well, that happens, but it also happens the other way. The biota controls the water. And further, with that third hypothesis, says, well, it's not just one direction or the other. We have interactions and feedbacks, and those are really important to consider also in this research of ecohydrology. So getting even more detail, the second bullet here talks about a pretty neat book in ecohydrology. It's about a decade old now, but they tried to outline some of the fundamental elements of ecohydrologic research and what it should help us to understand. And going down through these 5 bullets, I tried to draw upon these to help me assess our own research in ASABE to see where we stacked up in some of these areas. And so the things that I focused on were this bidirectionality of the hydrological and ecological system. How well are we doing in researching that aspect, not just one direction, but also the feedbacks, both directions? Are we doing a good job understanding the fundamental processes? A lot of the modeling that we do helps us to inform what are the important parameters that we need to identify through data, as Dr. Chauby said. How do we inform those parameters by understanding the fundamental processes? It's not enough to just establish statistical links, but to try to understand that chain of causality. I think that was a very good point. We need to be studying and understanding the full range of natural and human-impacted, water-dependent habitats and environments through the whole range of biota and ecosystem connections that could be present. We need to focus on processes, process interactions at a range of spatial and temporal scales, and we'll talk a little bit about that. And of course, it's an interdisciplinary effort, and I know most people here don't work in their own silo, but connect with lots of other disciplines. Get us up there. So even though we don't do a good job self-identifying as ecohydrologists, we do get involved in a wide range of soil, water, air, plant level interactions at a range of scales with organisms and ecosystems in varying levels of complexity in rural to urban settings in all ecoregions globally. So it's hard for me to imagine that we don't do a better job of taking ownership of our ecohydrological leadership. But let's take a look at why this might be. So with this long history that we all presume we have and know we have in over 60 years in the record, how can I document that history in that ecohydrologic research? I broke it down into 7 elements, and again, this flows from some of the definitions that I've shown and others, but the cornerstone, I think, up in the top 3 bullets, I kind of lumped all those things together to try to assess the level of complexity of our ecohydrologic studies. And that complexity includes the complexity of the study, the complexity of the ecological element, I called it. Is it organism, collection of organisms, all the way up to an ecosystem complexity of that ecological element. But also then the third bullet, the ecological processes that we're studying, how complex were those? And I'll walk us through that. I lumped all 3 of those together as an ecohydrological index to help us see in a very simple way how complex are we addressing this ecohydrologic phenomena in our research. The other elements are more descriptive at to kind of understand what spatial and temporal scales we've been operating at, and some other ecohydrological factors and management as we've heard about in a lot of the presentations today. So breaking out this Ecohydrologic Index, this is all just to help you understand when I start to show the trends in the journal, to help you understand what my thinking is and how to interpret those kind of simple trends that I'll show in just a few minutes. So complexity, to me, I just rated it very simply from 1 to 4. If the study was simply just focused on the hydrologic processes and didn't really go into very much detail about the ecology, that started at a 1. All the way up to a 4, where you were studying the full ecological and hydrological system with complex feedbacks. And so you can see kind of a gradation of complexity of the study. Complexity of the ecological element flowed out of just some early definitions of ecology from Odom, ranging from small scale up to large scale in an organism sense. We probably very often work at the organism scale, whether it's a fish or a plant, or populations like a monoculture field of corn. We less often get into communities of these populations or into the ecosystem operating as a whole, but certainly that's where we should be striving, I think, or at least we should be working at all those levels. And the process complexity I rated also very simply from 1 to 4, starting with, is the ecological element influenced by the hydrological states and processes? So are we dealing at that level? Or multiple, the second bullet being multiple hydrologic states and processes influencing the ecological element? Or does the third bullet, the ecological element itself, influence the hydrological processes? Okay, are we taking the study to that level? Or are the ecological, not just the state or presence of that ecological element influencing the processes, but do the processes of the ecological element influence the hydrological process? So try to get a sense of where we were in studying the complexity of the processes that might be at play in that ecohydrological system. So as I was trying to understand what the footprint is of ASABE journals, I had quite a few, I don't know if anyone has teenage kids here, but I had quite a few WTF moments. And by WTF moments, as I looked at what ASABE is doing in ecohydrology, of course I mean, where's the footprint? Pause. Where's the footprint? What are we doing in ecohydrology? And some of the WTF moments came as I was looking at much of what we do in ecohydrology. I had a hard time rating very highly on my Ecohydrological Index scale because too often, and I give some examples here, and I could probably just go right down the list of a lot of my research as falling into this category too. Too often we look at that ecological system as a black box. We don't really try to dive in there and understand what's going on inside that ecological system and how that may be driving the responses that we're seeing. And so, although I recognize that research is studying the ecohydrologic system, I had a hard time rating it very highly. So I recognized that it was ecohydrological research, and I tried to understand what the characteristics of that research were, but I called it a low-level ecohydrologic study. The higher-level studies got into that ecological process and really tried to understand functionally what was going on and the interactions of ecology and hydrology. And so you'll see in my summary, which is coming up next, that I'll separate those out. Okay, so looking at 6 decades of research, one volume of the journal, one volume of every 10 years I looked at a complete set of all the publications in those 10 years, tried to evaluate at least a third of the publications, just randomly select the publications and try to assess the scope and complexity of ecohydrological research each year over the 60 years. And so starting in 63 up to 2013, what you see in this graph really simply is the black and blue lines are the percentage of publications in our journal in the NRES division, which over time was soil and water and then eventually including biological engineering. The percentage of the articles that addressed ecohydrologic topics. And so the black line is all the topics. The blue line slightly beneath it is just the topics that I would consider high-level ecohydrology by my index kind of matrix. And so you see, the good news is that those trends are increasing over time. We're having more and more studies that are getting involved in the ecohydrologic regime, which is really good news. And I think that's what we recognize as a committee, this growing interest in ecohydrology in our society. But the WTF moment was the red dashed line, which shows an almost flat dealing of the complexity of the ecohydrologic processes. We haven't pushed ourselves as a society, one of two things. Either we haven't pushed ourselves as a society in moving in the direction of studying greater complexity of these ecohydrological systems, or when we do get involved in the greater complexity, it's not coming to transactions of ASABE. Or the third is that my measure of ecohydrologic complexity may not be very, very accurate, but I prefer to think it probably is one of those first two. And maybe in the roundtable we can discuss what the issue is and why we're seeing that flat line, and maybe what we can do individually to help promote some improvement. My boss calls this a spaghetti graph, and sorry for that. But if you can either kind of squint your eyes and look at it, or kind of look at the black line, which is the average of all the 6 decades of ASABE publications. But you see the spatial scale that we tend to operate at, and probably not surprisingly, most of the research in ecohydrology is at the plot to field scale, from the meter to hectare scale. Certainly that's appropriate when you're dealing with an agricultural system, but I think as we kind of broaden our scope and think about ecohydrology in a broader sense, or think about these agricultural fields and plots within the context of a more functioning full ecosystem, we need to be starting to press into the larger scales, but also the smaller scales in understanding the process complexity. And hand in hand with that is, this one's maybe even worse, but the time scale that we've studied in these papers over 6 decades. But it shows a similar trend, and I think it goes hand in hand. Spatial and temporal scales of the research tend to go hand in hand. And here we tend to focus more on the day to seasonal responses of the system. And we definitely need to be pulling out into especially as we look at long-term land use change and climate change impacts moving into decadal periods, and push the scale in both directions. So where should our footprint be in ecohydrology? And I would contend that we really should keep doing what we're doing. That's good. We need to be working at the scales and complexities that we're working at. But we also need to be expanding into greater complexity and larger and smaller scales, and keep pushing our research in every direction to cover this complete scope of complexity, of scale, of factors. I didn't talk about the factors in management, but I think I'm probably running out of time. So how much time do I have, Rafa? Kind of scale how fast I go through some of these examples. Okay. Just take you through some examples. Back in 1973, as early as 73, there was a really good example here, I thought, of ecohydrological research in our society, where they were looking at how they could manage playas in western Texas to try to reduce mosquito infestations. And so understanding something about the ecology and the physiography of playas and how that relates to the presence or absence or population of mosquitoes. This study was a really cool integrative study that really was operating at the population scale for mosquitoes, and tried to develop strategies that could take advantage of what they saw at the full-scale playa system and improve it through management. In this case, digging trenches that concentrated the water with more steep side slopes to reduce the mosquito breeding grounds and thus reduce the mosquito populations. I thought a limitation was that they stopped there and didn't look at the broader impacts of those changes, like on predatory insects or bird species or bat species, what other factors in the broader community sense that could have been impacted by those same changes in the ecosystem. And they kind of miss some opportunities to kind of stretch their scope and complexity. Here's a composting example. Composting being certainly operating at a community scale, not just an organism or a single population of organisms, but a whole community of organisms. And what I thought was really interesting about this one was the effort to push it down into the smaller scales. So using these phospholipid fatty acid indicators as indicators of community structure. And so going down to the cellular level and relating that back up to the structure of these communities that were responding to the environmental and hydrological conditions and making that connection. And so to me, this took a step towards greater scope and complexity of ecohydrologic research. Missed an opportunity to study feedbacks and how those communities then would also influence moisture contents and temperatures and so forth of the compost itself. So they looked in one direction but not back the other direction for those feedbacks, which maybe was a missing opportunity. Let's see, I get the next one. This is a pretty neat study. It's a fairly simple assessment, I think, of crop yields. But the interesting part of it was how they related so many factors to trying to be predictive about crop yields at the county scale. And so if you look at the factors in that first bullet, precipitation ET, they're looking at hydrologic factors, they're looking at biological factors, chemical factors, and physical factors, and trying to relate all of those to the biological state or that crop yield. And so although the ecological response was very simple, crop yield, once a season, take a measure of the yield per acre, the relationships to that yield was fairly complex and fairly multidimensional. So I thought that was a pretty neat example as well. Some work we did in, that kind of sounded a little bit similar to example that Dr. Chauby had. We were working with Kansas Biological Survey, and they had quite a bit of data back through multiple decades of the presence or absence of fish species. And again, presence or absence being a more robust indicator than population density. So where were the fish present, where were they absent? And we tried to relate those to hydrologic indicators. So a whole suite of trends in hydrologic factors over the period where we saw the diminishment of these fish species throughout a lot of different water basins in Kansas. And this research kind of honed in on two specific factors that showed a significant relationship to the decline of these fish species, or disappearance of these fish species in water basins throughout the northern part of Kansas. And so there, connecting the biological data to some fairly detailed trend analyses was instructive in seeing what was causing this disappearance of the species. And then conversely, what then could you do in the future to reverse that disappearance? What are the key ecohydrological elements you need to focus on to regain those species in these areas? And drawing an example from a really applied Everglades example, here we are using the ecological elements as targets for hydrologic management. So in this case, by understanding what the seasonal, so the temporal and spatial targets are for each of these various kind of indicator species within that Everglades system, what were their water needs? And what times of the year did they have those water needs? What were their ideal targets? Then can we take that understanding, and Ian, or if you're still here, is going to be involved in modeling how we try to manage the water to achieve those targets for all of these species in some type of optimal way. They each have different targets, different times of the year, and sometimes competing interests, and how do we try to manage the system to reach these targets? A lot of research tied up into that question, and I think addressing that whole system from this perspective adds a lot of complexity to how we deal with the ecohydrological system. And then finally, maybe a little mixed opinions about this video, but if you haven't watched this video on YouTube, I love it. I think it's really interesting how wolves changed rivers in Yellowstone Park. They present, although a complex, it's still a somewhat simplistic view of what the factors are that change these rivers, but I think the value of it, I think for our membership, is just to open our eyes to the various impacts that come from changing one element of an ecohydrologic system. In this case, the reintroduction of wolves changed the whole prey structure, which changed the whole grazing structure, which changed the whole vegetation structure, which led to documented changes in stream stability, in erosion, and vegetation condition throughout the Yellowstone. And so by changing one element, the impacts that reverberate through the system through these cascading effects is really interesting and challenging. And so when I see studies, again, my WTF moment as I'm looking at our own research, how we look at one specific aspect and don't open ourselves up to the broader implications of these changes that are being made that Dr. Chalby alludes to. So where should we be? To me, it's not about always trying to operate at the highest complexity, but covering the full range of complexity, full range of scales, and full range of management and factors. And our challenge, I think, and that we'll hopefully be able to explore in the next few minutes here, is will we expand the complexity and scope and scale of our ecohydrological research? I believe it's a researcher decision. I think that we're already heading down that avenue, and maybe with a nudge, maybe today's nudge will inspire people to take it that next step, to open up the blinders, to look at a broader scale and increased complexity, and look for ways to incorporate that into your existing research, and it's clearly within ASABE's scope and expertise to do so, and I'd just like to encourage everybody to try to get there. So WTF, ASABE, let's work on our footprint. Thanks very much.